Welcome back to trigonometry. Let's get started. So far, our trigonometry has only involved angles bigger than 0 degrees and smaller than 90 degrees. For example, we can't say what sine 0 degrees, cosine 143 degrees, or tan 212 degrees mean because we haven't run into them yet, but these could all be useful for us in practice. The reason we haven't examined these angles yet is because we've always been working with right-angled triangles, and the two extra angles in a right-angled triangle are always less than 90 degrees. Because of this, we'll have to look elsewhere to make sense of the trigonometric functions for other angles. Right triangles won't be able to help us here. For that, we look at the unit circle. The unit circle is a circle centered at the origin with a radius of 1. We call it the unit circle because the radius is just 1 unit long. The unit circle is really important in trigonometry, so let's take some time to familiarize ourselves with it. The center is at 0, 0. The radius is 1. It intersects the x-axis at 2 points. 1, 0. -1, 0. It also intersects the y-axis at 2 points. 0, 1. 0, -1. The radians are the angle made when the radius is wrapped around the circle. 1 radian is about 57 degrees. In a half circle, there are pi radians, which is also 180 degrees. So, pi radians equals 180 degrees. So 1 radian equals 180 degree divided by pi equals 57.2958 degree. Approximately. To go from degrees to radians, multiply by pi and divide by 180. The unit circle on the bottom tells us how the unit circle can be divided into radians and where those radians lie on the graph. Here is a table for some common angles in both degrees and radians. For small angles, the values of sine and tangent are almost equal to the value of the angle in radian. Look at the table on the right. The values get closer and closer the lesser the radian values. Also, the cosine function approaches 1 for small radian values. Look at the table on the bottom right, and we can see that it's true. Here's a table filled with some common radians and its sine, cosine, and tan values, similar to the ones we observed in right-angled trigonometry. Take a look. That's all for this lesson. I'll see you in the next one.